Alright, this may be a mistake, but let's go into a medium one blind. Alright, we got number 11, container with most water. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so it seems pretty straightforward. I'm just gonna think through to make sure if there's not a faster way I can do this. Because it seems pretty straightforward in that you could, if you wanted, just check every possible combination. But I can't help but feel like there's a faster way. So for example, this right here, we have these two lines, they make the biggest container of water between them. So it's just a rectangle with the two axes being the lower line and the distance between them. So it's just kind of like a math question. It's just like how do we make this run as fast as possible? What kind of redundancies can we eliminate? Well, how about we just think through it on this example right here. So we have, by the brute force method, we would just say, okay, check the distance between this. We'll check how much these two can contain, then these two, then these two, and then these two, and so on. Yeah, so I guess we could just do a brute force and see if that's really much slower than what everyone submitted. But I am going to think through this a little bit more. Okay. So we can go one, let's see. This container can contain 49. So what redundancies can we eliminate? You could work sort of like backwards in terms of distance, because you can't sort it. And sorting wouldn't really, I don't even think, help you that much. I mean, yeah. You could work backwards in terms of distance. So start with the longest gap. And then work backwards from there. Then do the gap of n minus 1, because you're not sure how long these lines are, but you can be sure about one axis. And I'm thinking that maybe if we work backwards, then we'll reach some point where we're guaranteed that no more lines will be bigger. Let's see, are there any restrictions? No, the height can be huge. I don't know, maybe I'm not right about this. Should I just brute force it and see what happens? Maybe I'll think about something on the way. Maybe. Okay, because these two lines, in this example, they're awfully far apart. It's a weakest link sort of thing because the lower line determines how high it is. I don't even think that it would take that much more time to just calculate the full value because it's just one operation. It's just one multiplication. I can't imagine that adding that much more to it. And I feel like if we try to figure out a faster way of doing it, we're gonna have to worry about like more and more edge cases and stuff, as opposed to just checking all the possible combinations. Well, there is one elimination we can make. We know if we're working left to right, we know that once we do this one, assuming that we check all combinations to the right of a certain line, then once we do this one, there's no need to check a shorter line because it's impossible for that to have a bigger. Okay, yeah, so just brute force with one extra step. Okay, that makes sense. So to make that clear, I'm essentially brute forcing it. I'm saying, okay, take the first line and then check to see if the biggest container is between 1 and 2, then 1 and 3, then 1 and 4, then 1 and 5, and so on. King of the Hill method, hold on to the greatest possible value until you find a greater one. But we don't need to we can ignore an entire line if we check the prior bigger line. That seems like enough to me. I'm gonna guess that that's beats like 60% of run times because I'm imagining that a lot of people just did a straightforward brute force, but I could be wrong. I could be wrong. Let's find out. 1, 2. Okay, let's do this. Let's implement it. Max area. So we're gonna have max area. That's what we're returning. Okay, so let's just implement the brute force thing. And you can't do, I'm assuming that there has to be at least 2 lines. Yes, there does. There does have to be 2 lines. So that means that we don't have to worry about checking the last one. Which means that we can just do, let's say n equals length of height. I feel like that's going to come into play later, but I could be wrong. And then range is n minus 1 because we don't want to check the last one and it's exclusive. Range is exclusive for the upper bound. Okay. So, pretty straightforward. We're going to just say area. Well, I guess this would be a nested loop for j in range I plus 1 n. Okay. Be a nested loop. So already looking at O n squared time. Hopefully there's a faster way that I think of. I can't really think of a way without doing like a nested loop. So yes, it would be O n squared, but I'm hoping that I can lop off most of the time that like functionally it's pretty fast. Not like theoretically. Okay. So area equals what would actually be the way you calculate the area? It would be I times, well, I, or J minus I times, that's the horizontal axis, the length, times min height I height J. Okay, makes sense. I feel like I'm really learning stuff here because that was a lot easier than it was to think about than it was a few problems ago. I'm glad I'm doing this. All right, that makes sense. If area is greater than max area, actually, we could say max area yeah, cool. Max, this is cute. So we're using the min and the max. Okay, and then return max area. Does that work? Yes, it does. All right, well, how does it do for time? That's not good. That's taking this long. Yeah, time limit exceeded. Wow. That is not good. Wow. I thought it would be slow, but I thought it would at least finish. Okay, well, let's see if I was right in my idea of saying you never have to check a lower value. We're just going to say max left post. And when we find a new max container, the new max left post will be height I is the left post. And then before we even bother going through the rest of them, we're going to say is height. If height I is less than max left post. Continue. So continue, quick keyword. I don't know how kosher it is, but just as a way to continue on to the next loop. I think that makes sense. There's probably more things I can lop off, but I think that makes sense. I'm saying you don't even need to do the subsequent left posts if they're shorter than the other one. I know I've said this before, but it's because once you check this one, anything shorter will never have a greater value. Will never have a greater area. Could I do something the same for the right post? I don't know, but let's see how that does. Time limit exceeded. Okay, but I got one more test case. So I was right, sort of. I feel like I'm trying to get to the moon by like climbing progressively taller trees. I really think I'm gonna have to rethink my entire solution, which is frustrating because I've got so many of the test cases passed. I'm gonna just comment out this whole thing. Just to hold on to it. And try to figure out a better way to go about it. Usually anytime I've found, just intuitively, I found that anytime that there's like a problem of efficiency, that for some reason like maps seem to be the vastest solution. So what's a way that we could like, I don't know, how can we, because it's already a problem, because those are some pretty big test cases, so it doesn't make sense to have a loop. Could we do like 2 pointers? Oh, hey, hold on. Maybe what we need to do is essentially do the same thing backwards. Because the second we find the rightmost post, well, the second we find the tallest post on the right, well, sort of. Because it is possible that a post on the right is shorter but results in a larger container, provided the distance is long enough. It's just not possible. Yeah. Okay. So maybe we need to. So I guess I'm glad I did this because it was worth checking. There's no need to make it harder on myself when it didn't need to be. Is there a way to quickly sort an array? No, sorting the array would take forever, right? Yeah, so first thought would be like sorted, but no, that would already take so much time. It's got to be like some math property that we can use, like some index value that we can come up with to like rank the eligibility of each possible post. I feel really dumb at the moment. Okay, so the leftmost. It's two values at once. You're checking the furthest one that's also tall enough. Okay. The above vertical lines are represented by the array. Okay. So what can we do to make this faster? If you're watching and you're screaming at the screen, I apologize. How do we make this faster? So right away, the reason why this is takes so long is because of this little guy right here. It's because of this little guy. This guy is saying that each value has to check the remaining values, giving it O n squared time. I just don't know how we can cut off any more possible comparisons. What can we do? So, like, let's just work through it and see if there's any useless operations I'm doing. So I'm saying, okay. So 1 is less than, yeah, so 1, start, okay, saying 1, 2, 3, 4, 5, okay, so 1, 2, 1, 3, 1, 2, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. And it finds the greatest value between those, which would probably be like, it would just be 1 and 9. Okay. Then we have 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9. And now we set a new value. We're saying we never need the left post. We never need to check that if the left post is less than this. Or if the left post is less than a prior left post. So we don't check that. We don't check that. We don't check that. We don't check that. We do check that. The problem is that these test cases are designed pretty well. And so yeah, that's good. You can see the values are all increasing. So that just means it's n squared time, which is really long. Because this line of code is never executed. Cute. That is awfully cute. So how do we work around that? Can we make it bidirectional? What if we figured out the theoretical possible values? The theoretical possible max container sizes. And we just worked backwards until we found a combination that lined up with that. That could be something. So instead of, so like for example, this one has 9. It has a max distance of 9 between this one and this one. And it has a max height of the second highest value. Which would be Well, I don't know how we'd get the second highest value. I'm just like shorthand. I mean, I know how we'd get it. I just don't know how we'd get it shorthand. So maybe we let's just use the max. Let's not try to find the second highest. Because I think the second highest would require us to. Ah, well, we could, like. I don't think it would save us that much time. We could, like, take the max, remove it in a copy of the list, and then get the max of that list, but I don't think that would save us much more time than what I'm going to say. So here's plan number 2. Plan B. Count backwards from potential max. Okay. That could work. But how? So we calculate the theoretical max. Step 1 is take n times max height. Okay, yeah, I was just checking to make sure some syntax was right. Okay. So we take n times max height. That's the potential max. Okay, step 2. Count down from potential max. Step 2a, I guess because it would be a loop. Or step 2a. Check to see if any combination forms max. Oh, actually, yeah, this will be way faster. Because we would just iterate through the possible factors of it. Okay, that's something. So how do we do that? So we have, let's do 2ai. Find all factors of max. 2ai. Check all possible pairs with that distance. to a III if lower post is the other factor. That could be something. I don't know. Maybe. I hope. If not, I really gotta hunker down or something. I don't know. But I think that could work because I think it's just eliminating a lot of checks because you kind of want to work backwards in terms of distance because the biggest container probably gonna have a pretty good big distance unless there's like an extraneous value. Oh, here's the problem. I guess there could be like one. That maybe wouldn't work either because there could be a problem. There could be a test case where there's a distance between two posts that's like 1 and they're really really big because as we saw by this, the height can be 10,000. So you could have a really long array of really short posts with 2 that are really tall. And there probably is there probably is one of those. And that would probably exceed the time limit. No, maybe not, because this could be maybe ON time. No, it'd still be a nested loop. What if we just build it and see what happens? At the very least, I learned something. Okay, so potential max equals so n is the length of height. Potential max is n times max of height. Okay. All potential max, meaning that we're just going to count down okay. We're just going to count down that potential max. We're going to count down the possible distances in this operation because only so many numbers can multiply to be that possible max. So right here, the possible max is 9 times 8 is 72. How many factors does 72 have? It's got 2, 3, 8, 9, 4. I still feel like I'm just trying to climb taller trees. I don't know. I still feel like it's might as well build it. You know, I feel like there's just some method that I'm totally ignoring or that I don't even know yet. Let's just make a helper function And this helper function will just iterate through the possible distances backwards. No, actually, we don't need to do reversed. My apologies. No, but we kind of want to do reversed. It's probably just a preference thing. We want to be reversed because we're presuming that the higher factors would result in more, but I guess it's not a matter of resulting in the higher factors would result in would appear in more maxes, but I'm sure that there's a test case where that would be untrue, and it really has to work for all of them. I'm just gonna keep building, and it's not gonna work, but that's okay. Okay. If I for n for I in reversed length of height. If I modulo no, if num modulo I equals 0, reversed, I guess it'd be range one length of height plus one. That's getting really ugly, but I'm gonna push through anyway, because this is how I learn, is by doing the stuff I don't want to do. If num modulo I equals 0, factors dot append I. Return I. Which I return factors. Okay. All right. I was gonna say call this get factors. N is the length of height. Potential max is n times the max of height. While the potential max is still there. We're gonna say get factors potential max. For f in factors. This is getting ugly. For f in factors. for I in range, length, height. No, we can just do n minus f. Here's to catch you up on what I'm thinking. I'm thinking that, let's say we start by saying, okay, well, we know that since it's 72, one of the possible factors should be 9, which means that we should check the posts that have a distance of 9. So we'd iterate through 1, and then we'd add, or 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Actually, would it be 72? Because this is 49 because it's 1, 2, 3, 4, 5, 6, 7. That's 7 tall. So it'd be actually the length of height minus 1. Okay. Potential max is the distance between the furthest possible posts minus 1. Times the max height. I'm just trying to figure out a way to outsmart this, because the problem is that the values can be so high that I can really see any possible combination. That would mean, like, if you went through left to right, or even if you like went middle out, because, you know, the largest possible distance is the first one, the last one, but there is a possible combination that would be the middle two in a really big array with a really high values. So I'm just going to keep building this and see what happens. Probably is not going to work. Oh, wow, this is really defeating me mentally. For I in range n minus f. Okay, n. I'm just going to keep that. Yeah. For I in range n minus f. So if a factor this is going to take forever, though. If a factor is eight, let's see, it's 8 times 8. So it's actually 64 is the highest possible value. So if we're starting with a factor of 8, then that means we would want the range to actually be 0 plus 8. Yeah, it could still be n minus f because we can just add on the factor. If height min height I I oh my gosh, height I plus f times F equals potential max. Return potential max. Oh gosh, does this even work? Oh my gosh, that worked. I can't believe that worked. Now, I don't think it's going to work in terms of time, but I'm actually really surprised that worked. Honestly, that's enough of an achievement itself. I'm back. I'm mentally back. I'm just going to say, like, return -1 as a last resort. Okay. So we see what I'm going for here. Let's see if that works. That'd be crazy. I still feel like it's going to be too long. Wrong answer. Oh, yeah. I guess this whole get factors thing. Yeah. What if we just said return 0 instead of return -1? You could also just say return potential max. Yeah, that's what I thought. And it's slower. It is slower. Okay. So that was plan B, and it, like I thought, was still going to be slower, which makes sense because I said out loud that the problem with the prior one was that it was a nested loop. And so for really big values, if you're going through every one double over, then that's just going to take too long, especially when the test cases are as well made as they are. And this one, I just added loops. Is the factors too much? Should I just work backwards in terms of distances? Was I overthinking it? Instead of doing factors, should I just try working backwards in terms of distances? I still don't think that'll work, but let's see if it works any faster. Because at least this doesn't have to calculate the factors for all possible numbers. Let's just say, because that only lops off so many. Because there's any possible combination of numbers, really. It only lops off so many at a time. So we're going to say for I don't know, for in range I don't know, does that work? I'm going to change it to D, because D is the distance. Okay, so to say it out loud, I'm saying that I'm decrementing through the possible max distances between the two winning posts. Assuming that the distance plays a big role, but it might not. It's not going to work. Yeah. I think this is going to be faster than the factors. But it was not faster than my original plan. Alright. I'll just come back to this one. Jeez, I don't know. Alright. Welcome to the part where I think I'm actually going to solve it. So, a little bit frustrated. I won't lie, I did take a quick look at some other resources, but I quickly looked away because I knew what to do from there. It was kind of a angry eureka moment. I realized I had actually said the right answer out loud multiple times. I just had not figured out how to make it work. But had I continued down that pathway, I thought I definitely would have found the answer. So I had the right idea with my first guess, actually, by saying iterate through from the left side. And then, yeah, you can just, you never had to worry about a possible, what was it? About a left post if there was a prior left post that was bigger. And I remember saying that maybe I could update the right post. But I remember saying that that couldn't work because there is a possibility that there could be a right post down the line that's smaller, but is still what was it? But is still part of but it's still part of the solution. Wow, I'm definitely sick. But yeah, if I just have two pointers running at once, I can make it be a single loop instead of a nested loop, and that will make it on time instead of on squared. All right, let's do this. Now, how do we make this happen? We're gonna say L equals 0, R equals length of height minus 1. Because those are the indices of the leftmost and rightmost one. Now we can just say while L is less than R, because we'll just basically move those pointers inwards. As we go on. And we're going to say, first we're going to do that king of the hill thing. Max area is still equals 0. And we can really just do one line. We can say max area equals max between, we'll store, okay, area equals R minus L. That's the distance times min height R height L. Okay. Okay, cool. All right. Now we can move the pointers in. First of all, we can just return it at the end. Return max area. Now we can just move the pointers in at the end. And it'll work like this. Here's going to be the trick. We have these two. If we have this one and this one, and we're going to tick them in over time. We can't take them both in because we'll be skipping a possible combination if we eliminate two possible posts at once. But we can instead tick one of them in. And if we tick the lower of the two inwards, being we have this one right here, and we move to the possibility of the left post being this one, it's possible that it grows in height. Oh yeah, that's it. Okay, so we have two posts. Whichever one is lower, you move inward with that one to try to get maybe a higher post. So you're sacrificing distance between them for a chance at a higher post. And that way you can handle, you will never be checking, because basically, okay, so this is the furthest possible distance, is 1 and 9. So if we get rid of that possibility of it being 1 and 9, well, no, if we check that already, and 1 is the smaller option, and that means that if there is a bigger value than 1, since these are the leftmost and rightmost ones, if there is a bigger value than between those two, it will definitely not include 1. Because 1 is the lower option, is the lower value. Right? I think so. Because 1 is the lower value. So as soon as, yeah, since there's no, that's the greatest possible distance. So there's no way that 1 is included unless, could it be like, what if this one was like really big? It doesn't matter because it's the lower one. Yeah, that's it. Okay, that's definitely it. It doesn't matter how big the other ones are. This is still how high it can be, which means that once we've checked that since this is the greatest distance we could have, there's no possible greater area that includes this one. So we can just move that one in and ignore that. There it is. Fine. Figured it out. Let's implement it. If height is greater than height of L, L plus equals 1. Run that. Oh. minus equals 1. Okay, and it works. Let's see if it works for all of them. Yes, it does. Oh my goodness. Well, that's embarrassing. It was a lot simpler, and I had also said the solution out loud, and I need to go elsewhere to get pointed in the right direction for a little hint. But yes, of course, that is the solution. We have a left pointer and a right pointer, and we do a King of the Hill style max. And we say, okay, while this is the condition, because we don't need to, once they cross over, we've officially, there's no more possible distances between. You can't have negative distances. We calculate the area, we check if that's the new max, and then we move in from the lower option, because there's no possible way that the lower option is included in the max, because since the height of the container is determined by the lower value, it doesn't matter if any remaining values are higher. It's still bound by that lower one. There it is. Way simpler than I made it. Just a little finicky. Instead of doing 2 loops, just had to use 2 pointers. But we're done. We're past it. Thank you for bearing with me. Love you. Goodbye.